Default masks, classes, and private addresses. Let's jump in. I know your time is precious, so here's the gig. If you know the answers to these questions and are comfortable with what the correct answers are and why they are, you can go ahead and skip this video, and you know what? You and I can have just as much fun in the very next video. On the other hand, if you aren't as comfortable as you want to be with any of these questions, have no fear. We're going to cover each and every one of them in this video. So pause me right now, read these questions. If you want to go through this content, I am absolutely looking forward to it. When looking at IP-v4 addresses, there's three distinct groupings. They call them classes of addresses that we can work with for usable IP addresses for hosts. And they include Class A, Class B, or Class C. So here's what I'd like you to do. I'd like you to jot down on a separate physical piece of paper. I don't care if you use a pen or a pencil, but what I've discovered is that writing things down gives one additional sense as far as learning it, and it'll help you remember it. So the three classes of addresses are A, B, and C. Now, the way you recognize a specific class of address is we look at the very first number before the first period right here. We look at the first number, and if it's in the range from 1 to 126, it is it's a Class A address. If that very first number is within the range of 128 through 191, it is a Class B address. And for our third category, our third class, our Class C, if the very first number is within the range of 192 through 223 inclusively, that would mean that that IP address, regardless of what's following, is a Class C address. And the cool thing is, we only have to look at the very first number before that first period to identify the class of IP-v4 address that it is. So here's what I'd like to do. I'd like to do a little exercise with you where you and I can identify, based on the first number in the IP-v4 address, whether or not it's a Class A, B, or C address. And to do that, let's go ahead and use the command traceroute, which on a Windows machine is TRACERT. We'll use the -D. That means I don't want to try to resolve every single router in the path to a host name. And then we'll put in the IP address of a Google DNS server at 8.8.8.8. And what I would like you to do as well is I would like you to do this same thing from your computer. And I just want to remind you that that -D on a Windows machine will save us a bunch of time because it won't try to resolve the IP address we find in the path to a name. So let's go ahead and press enter, and our first hop is my internal router at 192.168.1.1, and then we're going out to my service provider's network at 10.72.0.1, and then off to other internet routers at 24, etc. And it looks like the device at hop number 12, whatever it is, doesn't like feeding back the information regarding our time to live expiring, which is the way traceroute operates. So here's what I'd like to do. Let's go ahead and take this IP address right here, 192.168.1.1, which happens to be my first router in the path between myself and 8.8.8.8. And my question for you is simple. Is this address a Class A, B, or C address? So take a moment, think about it. Is it a Class A, B, or C address? Now you might be saying, oh, this is easy. I'm going to look at this chart over here. And you said, Keith, all I have to do is look at the very first number, which is 192. And 192 is in this range right here, which makes it a Class C. You would be absolutely correct. Fantastic. Let's do yet another one. How about this one right here? This is 68.105.30.181. What is that? Is it a Class A, a Class B, or a Class C address? And again, if you're saying, well, Keith, that's easy. I simply look at the very first octet only, the very first number in that IP-v4 address. It's 68. I find out which range it fits into, and boom, it's a Class A address because the number 68 is absolutely within that range of 1 through 126. Excellent, excellent work. And here's what I would like you to do right now. If you've done your own traceroute, which I hope that you have, I would like you to pick the fourth hop, whatever that is, the fourth hop in your own traceroute, and using that fourth hop, whatever IP address that is, I'd like you to identify, is that IP address that is your fourth hop, is it a Class A, a Class B, or a Class C? Now, if you're on a device that doesn't have the ability right now to successfully do a traceroute, you can go ahead and use my fourth hop, which is 24.234.6.185. And once you've identified that as a Class A or B or C address, again, based on that first number before the first period, You can go ahead and resume the video and we'll proceed. Meanwhile, go ahead and pause me while you work out the class of that address. It is really important to do these expert exercises as I assign them in this course, and I want to take a moment to personally thank you for investing that time to do that exercise. The next thing that I'd like you to do right now is on a piece of paper, I would like you to write out this table of classes. And it goes class A is 1 through 126, class B is 128 through 191, and class C is 192 through 223. What I want for you is the ability on demand to go ahead and write those three classes out. That way, if in any situation you need to remember what's a class A or a class B or a class C, the exercise that we're doing right now of having you write that out will assist you in measurable terms in remembering that first octet and the ranges associated with each class. So take a moment, pause me, and write that out right now. So thank you for taking that next step into mastering IP addressing. That's fantastic. Now, one of the questions that I get a lot is, hey, Keith, I see this is 1 through 126, and I see that class B starts at 128. What happened to 127? Well, in measurable terms, 127, an IP address that begins with that, really does fit into the class A address space. However, the 127.anything is a reserved loopback special purpose address. We can't assign that to an actual interface on like a computer or a router or anything like that. It's set aside for special purposes. So we can't actually use 127 in a production sense. The other question I seem to get a lot, and I want to talk with you about it right now, is why in the heck do we even care about if it's a class A or a class B or a class C address? And the reason we care is because there is a default mask, that identifier that tells us exactly how much of that IP address going from left to right, how much of that IP address is the network address. And that's the primary reason why we care. So let's write out some IP addresses. Let's say we have 10.1.2.3, and let's say we take a class B address, the first octet, the first number being, let's say, 130.6.9.250, and let's take a class C, and let's take 200.100.4.5. So we have a class A, class B, and class C address. The biggest reason why it even matters at all is because the default mask, which is controlling which part of the IP address is the network and which part is left over for the actual host, for a class A, the default mask is the first number. With a class B, the default mask is the first two numbers. So first number, first two numbers, and for a class C, any guesses? And if you're saying, hey, Keith, I'll bet you it's the first three numbers with the class C just because of the pattern, you would be absolutely right. And that, my friends, is important to know with IPv4 addresses. The default mask, which is associated with a class A, which is different than the default mask associated with a class B, and different also from a default mask associated with a class C address. So here's the expert exercise that I'd like you to do right now. On a piece of paper, I'd like you to write out the following: that a class A address uses the first number as network, which means that the mask is taking the first full number as the network address, leaving the last three numbers for host addresses. A class B takes the first and second numbers as the network address, which leaves the last two numbers for host addressing. And a class C address uses the first, second, and third number as the network address, which leaves the last number for host addressing. So take a moment right now, pause me, and go ahead and write out the fact that class A has the first number as the network, class B has the first and second number as the network, and class C has the first, second, and third number as the network address. So let's go ahead and test what we've just learned and apply it. We're going to do another trace route, and we'll say don't bother doing the name resolution, and let's go out to 8.8.8.8 again, and we'll press enter. And as that completes, I'm going to do a Control C so it doesn't time out on that last one. Here's what I'd like you to do. Let's go ahead and take number 9 in this trace. So number 9 says 72.14.238.2. Now that represents, on the public routable internet, some IP address that's associated with a router on the internet. In fact, that router happens to be in the path between my computer and the destination of 8.8.8.8. And what I'd like you to do is tell me, with this address, 72.14.238.2, I would like you to tell me, if we were using the default masks associated with class A, B, and C, which portion of this IP address right here would represent the actual network address, and which numbers on the right would represent the actual host addresses. So I'd like you to take a moment right now, pause, and based on what we've talked about in this video, go ahead and answer that question. And then when you're ready, unpause me and we'll take a look at it together. So the way I would approach this, I would say, first of all, which class of IP address is this? Is it class A, B, or C? The only thing we have to look at really for that is the very first number, which is 72. 72 falls in the range of a class A address, and based on that, we also know that the default mask for a class A address is taking only that first number. So this would be the network right here, and all of these numbers to the right by default would become the host addresses. So let's do it one more time. We'll choose a different IP address this time. Let's go ahead and choose this guy right here, 216.239.48.167. So 216.239.48.167. My friends, if we were using the default masks for this address, how much of this IP address would be the network, and how much of this address on the right would be the actual host address? Where would that dividing line be? So I can see the light bulb going on for a lot of you right now. You're saying, okay, Keith, I got this. This is 216 is the very first octet. 216 falls in a class C address, and by default, for class C, it's the first three numbers are the network. So the network address is 216.239.48, and the leftover portion, which isn't consumed by the mask, is the host address. And if that's what you thought, you are absolutely correct. For the defaults, you find out what class it is first, and then secondly, you apply the default properties for the mask for that address. In the case of a class C, the first three numbers are the network address, leaving the last number for host addressing. Another thing that I'd like to share with you right now about talking about this network 216.239.48, again, if we were using the default mask, is how would we write that out? And what you could do is you could write out 216.239.48.0 when we're talking about the network. Because when we're describing just the network, we don't really care about host addresses. So everything to the right of the mask, if you will, you can go ahead and zero out when you're just talking about that street or that specific network. So we could say that this router is living, if we're using the default mask for a class C address, that router is living on network 216.239.48.0. And his actual host address is 167 on that network. The next thing I'd like to chat with you about is terminology. Sometimes we'll hear the term of network or subnet. And really what that is a network is like a street on a computer network. And a subnet is like a subdivision of a street on that network. So very often when people talk about networks or subnets, from a loose perspective, we're really referring to the same animal. It's simply the street name for a given part of our network. So the last thing I'd like to chat with you about is private address space. Let's say, for example, we have the big cloud called the internet. And out there, we have a server, DNS server, a group of servers being represented as 8.8.8.8. Those are DNS servers from Google. Now, if they were using a default mask, which part of this IP address for their DNS, which part would be the network and which part would be the host? And if you're saying, okay, Keith, I got this now. It's a class A address, fits in that range, and by default, the first number is the network. And again, if they were using that default mask, the last three numbers would be the actual host address. Fantastic. So how exactly does that relate to private address space? Well, let's say we have a little company called Acme Incorporated, and they've got several networks. So they have a little router, and they've got a network here, network here, network here, network here, and they want to start using IP addressing. Well, what's preventing them from using the 8 network? Nothing. They could absolutely have this be an 8 network right here. And they could have a PC on that network, and they could have full interconnectivity, maybe the 9 network and the 10 network and the 11 network, no problem. And they could have full interconnectivity inside of their environment. Well, what happens if they try to connect to the internet? Well, normally what's going to happen is we're going to have a router. So I'll label that as router. And that router is going to do something magical called network address translation, where it's going to swap out the source address, and these customers, as they go out to the internet, they can go ahead and appear as whatever globally assigned IP address the service provider is allowing that customer to use. So you might be asking, okay, Keith, what's the problem? Well, I'd like you to consider this computer right here, PC1. If PC1 believes that it is connected to the 8 network, and it is trying to reach 8.8.8.8, which is a Google DNS server, this little PC is not going to try to use its default gateway. It's going to think, oh, I'm trying to get to 8.8.8.8. It's on the local network. It's going to start ARPing, trying to resolve that IP address to a layer 2 address. It's not going to have success. And what's wrong with this picture is that this PC will never get out to 8.8.8.8 if this PC believes that the 8 network is local. So what is Acme Incorporated going to do? Well, what they can do and what everybody can do is use what are called private address spaces. Inside of the Class A, B, and C address ranges, they have set aside special IP addresses that we can use anywhere we want to, and we won't have to worry about colliding with somebody else's IP address space. For example, we won't use an 8 here, and there will be a globally addressable 8 there. It won't happen if we use private address space. And so here's what I'd like you to do. I would like you to write out on a piece of paper these ranges, which are the private IP address ranges that are commonly used for IP-v4. In the Class A range, anything that starts with 10, boom, that first octet. If it's 10, that's the private address space that anybody can go ahead and use for their private networking. A Class B, we have a range of 172, that's the first number, and then 16 through 31. The numbers after that don't matter. So for example, on the 10 network, these last 3 numbers could be anything. With the Class B, 172.16 through 31, anything in that range. The last 2 numbers don't matter. It's still a private address. And then for a Class C, we have 192.168. Anything is also considered a private address space. And that's why in our IPv4 fundamentals video that we went through together, when you did an IF config on Mac or Linux or an IP config and looked at your IP address, it is very likely that if you're at a company or an internal network, it is very likely that you are using on your computer one of the IP addresses from the private IP address space. And again, to get out to the internet, we'll simply use network address translation to translate one of our private addresses into a globally routable address, so the internet doesn't really know what our internal private addressing space is. They'll simply see the address that we translated to during the NAT process. So take a moment right now with this expert exercise. Write out this private address space for Class A, Class B, and Class C. And when you have this table written out, go ahead and click on play. So here are the action items I would love for you to do. If you haven't already done the exercises assigned in this video, go back through and make sure that you do them. Remember, small and consistent steps are going to get us to that destination we want, which is mastering the idea of IP addresses and specifically custom subnetting with IP-v4. The other thing I'd like you to do is go back and take a look at the questions at the beginning of this video and walk through them and make sure that you're now comfortable with not only what the questions are, but the correct answers to those questions. I have had a blast. I'm so grateful for your time. I hope this has been informative for you, and I'd like to thank you for viewing.